45 meters below the surface of the Aegean Sea, inside a Roman merchant ship that sank sometime around 65 BCE, there is an object that took more than 2,000 years to understand. Not because it was damaged, because what researchers found inside it, once they cleared the corrosion away, should not have been there. A lump of bronze roughly the size of a shoebox, encrusted with coral after 2 millennia on the seafloor. Inside, 37 interlocking bronze gears, precision machined, calibrated to predict the positions of 5 planets, the phases of the moon, the timing of solar eclipses across decades-long cycles. The device predates anything of comparable mechanical complexity by 1,400 years. 1,400 years. That gap is not a discrepancy in a database. It is longer than the entire duration of the Roman Empire. Today I will show you 7 ancient machines that science cannot reconcile with the civilizations that built them. Each one surpasses the previous in a single specific parameter, the distance between what that civilization was supposed to know and what it demonstrably knew. By the end, we return to the bronze box from the Aegean, to the 37 gears, to the question of who designed a machine that tracked eclipse cycles using mathematics that should not have existed for another 14 centuries, and why that machine was on a ship, going somewhere, and we do not know where. Eastern Han Dynasty, China, the year 132 CE. Court astronomer Zhang Heng presents the emperor at Luoyang with a sealed bronze vessel 1.8 meters in diameter, modeled on the shape of a large ceremonial wine jar. On the exterior, 8 bronze dragons are mounted at the 8 compass points. Below each dragon, a bronze toad sits with its mouth open. When ground motion occurred at a distant location, a single ball would drop from one specific dragon's mouth into the toad below it. The direction of the drop indicated the direction of the earthquake. In 138 CE, the device registered an event. No one in Luoyang felt any vibration, no sound, nothing. The ball dropped from the dragon facing west. Imperial couriers were dispatched immediately. 4 days later, reports arrived from Longxi province, 600 kilometers to the west, confirming a significant seismic event on the exact date the machine had responded. Picture yourself standing in that imperial court, watching a bronze dragon release a ball for no reason anyone in the room could feel or explain. 4 days later, confirmation from 600 kilometers away. The machine was right. The court was silent. Zhang Heng left a detailed description of the device's exterior in texts that survive to this day. The internal mechanism he never described, not in any surviving document, not in any correspondence. Our best hypothesis is a pendulum system, suspended centrally, that resonated with specific ground wave frequencies below the threshold of human perception. But every functional reconstruction attempted by modern engineers has failed to match the directional accuracy he claimed, using only materials available in 2nd century China. We know what it detected. We still don't know how he knew. If the gap between what history says was possible and what the physical record shows actually happened captures your attention, subscribe. Each machine on this list widens that gap by one deliberate step, 2nd to 4th century CE. Across a geographic zone stretching from Britain to Hungary, from the Rhine to the Rhone, a specific bronze object appears in more than 100 separate locations. Each one is hollow, with 12 pentagonal faces. Each face bears a circular hole. The holes vary in size from face to face. The variation is precise and consistent across specimens separated by thousands of kilometers. Every Roman writer who ever put stylus to wax documented Roman military structure, agriculture, architecture, engineering, religion, medicine, law, and political gossip in exhaustive detail. Vitruvius wrote 10 books on architecture alone. Pliny the Elder cataloged the entire natural world as he understood it. Julius Caesar wrote his own battle reports. Not one surviving Roman text in any language mentions these objects. Not one. What they were called. What they were used for. Why the holes vary in the exact pattern they do. Silence. A museum conservator in the Netherlands named Nicole Volland spent 3 years testing the knitting gauge hypothesis, that the varying holes were used to determine the correct needle size for different thread thicknesses when making gloves. The math mostly works, but it doesn't explain why objects were found from Britain to Romania, or why the Roman army, which documented its supply chain down to the nail count, left no procurement record for a device this widespread. One recovered in France had traces of beeswax in the central cavity. What the beeswax was for, we don't know. What the object was used for, we don't know. The Romans documented everything, except this. We know what it was made of, we still don't know what it was for. Northwest Iraq, 750 BCE. British archaeologist Austen Henry Layard is excavating the palace complex at Nimrud, seat of the Assyrian king. In the rubble of a storage room, he recovers a piece of polished rock crystal roughly 3 centimeters across. The object is now in the British Museum, room 55, case number 9. It is a convex lens, not a naturally formed shape, deliberately ground into a precise optical curve. At the correct focal distance, it produces approximately 3 times magnification. Italian scholar Giovanni Pettinato examined it and argued the optical shaping was consistent with use in a composite astronomical instrument. Physicists examining it for the Galileo project in Florence confirmed the curvature was accurate enough to function as a component in a refracting telescope. Rock crystal, the material of this lens, is harder than any metal available to Assyrian craftsmen, grinding it into a geometrically accurate convex surface. Without glassworking tools, without an understanding of refraction theory, without optical calibration equipment, requires a level of precision abrasive technique that our histories of optics do not assign to anyone until the Islamic scholars of the 10th century CE, roughly 1700 years after this object was made. One camp argues this is a decorative polished ornament or a natural formation, not a functional optical device. The other camp says the specific curvature is too geometrically accurate, too consistent across the surface, to have any other purpose. Which argument are you closer to? Write it in the comments. The knowledge required to grind this did not exist in 750 BCE. The object exists. It has been sitting in a display case in London since 1853. We know what it is, we still don't know how they knew to shape it. 1st century CE, Alexandria. An engineer named Hero writes a book called Automatopoietica. The book survives today in university libraries. You can request a copy. In it, Hero describes a wheeled cart powered by a descending weight connected to ropes wrapped around the axles in a deliberate preset arrangement. Once released, the cart executes a complex pre-programmed sequence: forward movement, left turn, stop, reverse direction, right turn. No human hand involved after the initial release. The program is encoded in the physical pattern of the rope on the axle. Alter the rope pattern and you alter the output sequence. This is, by the operational definition used by modern mechanical engineers, a programmable machine. The same functional principle as a music box pin cylinder. The same principle as a Jacquard loom punch card. The same principle as the numerical control machining tools introduced to manufacturing in the 1950s. Hero's surviving texts also describe a coin-operated device that dispensed holy water when a coin dropped onto a lever. Automatic temple doors that opened when a priest lit fire on an altar, through a pneumatic pressure chain involving heated air, water displacement, and rope tension. A wind-powered organ requiring no human operator to sustain the airflow. An automated theater performing a 10-minute sequence of mechanical puppet scenes using a programmable axle system identical in principle to the cart. None of these were developed further, by any civilization, for the next 1,700 years. He left instructions. They still exist. No one who came after him in the ancient world appears to have read those instructions and asked what happened when you made the cart larger, connected it to a grindstone, attached it to a millstone. We know exactly how it worked. We still don't know why no one continued. 1936. A storage room at the Iraq Museum, outside Baghdad. German archaeologist Wilhelm Koenig picks up a clay jar 14 centimeters tall. Inside the jar is a copper cylinder. Inside the copper cylinder, an iron rod suspended without touching the copper walls. The assembly sealed at the top with asphalt. The object dates to the Parthian period, somewhere between 250 BCE and 250 CE. Koenig recognized the geometry. Fill that jar with an acidic liquid. Vinegar, grape juice, citric solution, all readily available in ancient Mesopotamia, and the copper and iron create an electrochemical cell, a battery. Laboratory replications in the decades since Koenig's discovery have produced sustained current of approximately 0.5 volts per jar. Multiple jars in series produce enough current to electroplate a thin layer of silver onto a metal surface. Archaeologists examining copper objects from the same region have found surface deposits consistent with electrochemical metal deposition on items that predate Alessandro Volta's invention of the first documented electrical cell in 1800 by approximately 2,000 years. Here is what does not exist: any inscription, any text, any carving or administrative record from the Parthian or preceding periods that mentions electrical current, electrochemical reaction, or any process resembling what this jar demonstrably produces. No theory, no name for the phenomenon, no instruction manual. The jar appeared in a museum storage room with no label and no provenance note. It generated electricity before anyone, as far as we know, had a word for electricity, and it points directly at the question the final machine on this list forces open. Not just what these people knew, but where they learned it. What cities produced the people who built objects like this? And what happened to those cities? Tarentum, southern Italy. Approximately 400 BCE. A mathematician named Archytas, a man Plato traveled in person to study, whose letters Plato incorporated into his own collected writings, constructs a mechanical bird. The ancient sources call it a dove. Lightweight construction, counterweighted, powered by steam or compressed air, fed through internal channels in the structure. The ancient authors Aulus Gellius and Favorinus describe it independently, writing several centuries apart, both saying the same thing. The bird moved through the air under its own mechanical power, sustained, until the motive force was exhausted. If those descriptions are accurate, Archytas produced sustained mechanical flight driven by a reaction principle in 400 BCE. The Wright brothers at Kitty Hawk were 2,304 years away. No physical remains of the device have been recovered. We have only written accounts from authors who were not engineers. That caveat is real. But Archytas is not a mythological figure. He is one of the most rigorously documented mathematicians of the ancient world, credited with the first recorded solution to the Delian problem in 3 dimensions, and with foundational work in harmonic theory. His intellectual relationship with Plato is among the best documented personal connections in classical antiquity. The descriptions of the dove are specific in their mechanism, not metaphorical. And if we accept that Hero, whose manual we can read today, built a programmable cart that no one thought to develop further for 17 centuries, then the question of whether Archytas's dove represents something physically achievable in 400 BCE is a question about our assumptions, not about his capability. The engineering required for what those sources describe did not exist yet, so we say. We return now to the corroded bronze box from the Aegean. 1901. Greek sponge divers working the seafloor off the small island of Antikythera, between Crete and the Peloponnese, bring up what they believe is a coral-encrusted rock from a Roman wreck. A spectacular bronze statue head surfaces with it and draws all attention. The rock goes into storage at the National Archaeological Museum in Athens. It sits there for 2 years. In 1903, a researcher notices it has cracked, through the opening, gears. 37 bronze gears. The largest no bigger than a spread palm, some with teeth barely 1.5 millimeters wide. The gear train tracks the Metonic cycle, 235 lunar months, aligning precisely with 19 solar years, the foundational cycle of ancient calendar reconciliation. It tracks the Saros eclipse prediction cycle spanning 18 years and 11 days. It tracks the Callippic cycle across 76 years. It models the anomalous motion of the moon across its orbit using an epicyclic gearing mechanism, a mechanical solution to a specific astronomical problem that does not appear in any documented engineering text anywhere in the world until the 18th century. A research team from University College London, decoding a section of the front dial plate that had remained unread for over a century, published findings in 2021, confirming the device also displayed the positions of all 5 planets visible to the naked eye simultaneously: Mercury, Venus, Mars, Jupiter, Saturn. Nothing of comparable mechanical complexity appears in any surviving record for 1,400 years after this device sank. The next documented appearance of differential gearing, the specific gear type that allows 2 shafts to rotate at different speeds simultaneously, which this mechanism uses, is in European clockmaking of the 16th century. The ship that carried this device went down around 65 BCE, heading west from somewhere in the eastern Mediterranean. The cargo also included bronze statues, glassware, silver coins. The device was not ordinary freight. It was built for someone, going somewhere specific, to do something we can only guess at. We have the machine, we have no record of the workshop that produced it, no name of the school that trained its designer, no text that acknowledges the existence of such a device, by any name, in any language, from that era. We know what it does. We still don't know how they knew. The person who designed those 37 gears came from somewhere, a city, a tradition of knowledge that passed from teacher to student across enough generations to produce this level of precision in bronze. That city existed. That tradition existed. And then the ship sank, and the box went to the bottom of the Aegean, and 1,400 years passed before anything mechanically equivalent appeared anywhere on the surface of the Earth. The cities that produced minds capable of building machines like the 7 on this list did not all fade slowly. Several of them disappeared in ways that archaeologists spent decades unable to explain, not because the record is incomplete, but because the disappearance was fast. One generation, a functioning city, producing engineers, astronomers, mathematicians, craftsmen working bronze to tolerances of 1.5 millimeters. The next generation, sand, silence, walls standing with no one inside them, and no document from the inhabitants explaining why they left or where they went. The cities that vanished from the map within the span of a year, without leaving a record of the cause, are the next layer beneath this machine. They are the harder question. 7 machines, 7 different centuries, 7 objects that do not fit the line we draw between primitive and modern. A bronze jar in China that registered an earthquake 600 kilometers away before any human in the room could feel the ground move. A bronze object present across the entire Roman world in 100 locations, mentioned in exactly 0 texts. A crystal lens ground in Assyria 750 years before optics had a theory behind it. A programmable mechanical cart in Alexandria, whose manual survived 2,000 years, but whose principle sat idle for 1,700 of them. A clay jar from Mesopotamia that generates electrical current from grape juice, 2,000 years before anyone documented the concept of electricity. A mechanical bird in southern Italy that 2 independent ancient authors say flew under its own power. And a clockwork astronomical computer from a Roman shipwreck that modeled 5 planets simultaneously, whose mechanical sophistication was not matched anywhere in the world for 14 centuries after it went to the bottom of the sea. Forward, each step enabling the next. Stone to bronze to iron to steam to computation. A single unbroken line. These 7 objects suggest the line broke. That knowledge reached a point we have not fully mapped, and then failed to carry forward. Not because the next generation lacked intelligence, because something else happened. Something that left workshops empty and schools silent, and machines sitting on the seafloor unclaimed. Perhaps the most accurate thing that can be said about human knowledge is not that we always advance. Perhaps sometimes the right word is that we remember, and then we forget. And then someone pulls a corroded box from the water, looks through a crack in the casing, and finds 37 gears that shouldn't be there. Place your hand on the oldest piece of metal near you. Somewhere in a museum in Athens, a gear no bigger than your thumbnail once tracked the orbital path of Jupiter with a precision no civilization was supposed to possess. They possessed it. Then the ship went down. Then the sea closed over it. And for 14 centuries, not one person on the surface of the Earth knew.